Hi, I'm Brian Uzzi from the Kellogg Graduate School of Management at Northwestern University, where we hosted the Second International Conference on Computational Social Science. In this video, 5 of our internationally recognized keynote speakers and renowned scientists discuss path-breaking computational social science research. This research has clear, real-world applications for the bottom line, decision-making, and consumer privacy. We'll start with Sandra Gonzalez Bailon of the University of Pennsylvania talking about political activism, and Marcus Strohmeyer from the University of Koblenz-Landau talking about bias on Wikipedia. Michael Kearns of the University of Pennsylvania discusses his fascinating work on how to preserve individual privacy while fighting terrorism. Microsoft's Chandra Hill discusses how to link online behavior and TV ads, and Sendil Mullainathan of Harvard University describes the benefits of machine learning for decision makers.
I'm going to talk about communication networks and how they facilitate large-scale coordination, mostly, as Laura sort of anticipated, in the form of political protests, but not only. Most of my empirical work focuses on political communication and social mobilization. Even if you're not interested in political mobilizations as I am, you might be interested in the broader theme of how network science and the many tools it has to offer can improve our understanding of social dynamics. Spontaneous coordination of human action is probably one of the most puzzling phenomena in the social world. Communication networks facilitate coordination regardless of the channels through which it flows. And this is me saying that social media is just a source to get data about those networks, and the reason why many of us are analyzing Twitter so much. And so understanding the dynamics of collective behavior is important because it allows us to understand social change. For a long time, the study of collective behavior and its significance for dynamics of change were seriously limited by the absence of appropriate empirical data. And this is what digital technologies finally changed. And this is the reason why we have conferences like this. Right now, I would say that there are 3 main approaches to the analysis of collective behavior, especially as analyzed through the lens of social media data. The first is the study of aggregated patterns of collective attention with a focus on temporal dynamics. The second refers to the analysis of networks of information flow with a focus on the structural properties of those networks. And the third refers to individual level mechanisms that make those other higher level dynamics emerge. And so what I'm going to do now is discuss some of the work that I've been involved in recently as it deals with each of these 3 levels of analysis. And I'm going to start with this mesoscale between the level of individuals and the level of aggregates, where the focus is on networks and on how networks facilitate the diffusion of information.
The group that I'm heading at GESIS is sort of on the intersection between applied computer science and social science research. And in a way, what we are doing is we're looking at sociological issues like the ones on the right: polarization, discrimination, radicalization, inequality, and others. And we try to explore these issues by looking at mostly web data, but also other data, and applying computational methods. Methods like classification, clustering, summarization, and so on and so forth. What I'm going to talk about today is one of these particular sociological issues, inequality, and in particular gender inequality as represented on Wikipedia. And we are going to apply a couple of computational methods to explore this issue. Why is it interesting in the first place to study gender inequality on Wikipedia? Well, it is the 7th largest website on the web according to Alexa. It exists in more than 200 languages, and it plays a dominant role in our general information processing capabilities as a society, one would say. Once you learned about Brexit, probably most of you typed in something into Google, and then what shows up? One of the Wikipedia pages that covers that event, of course. So it's an important resource that we want to look at because if the editor community is so dominated by a particular gender, we want to know whether this sort of creates problems down the line. And the way we want to look at it is in one particular way. So what we want to do is we want to look at how people are represented on Wikipedia. And in particular, we want to look at how notable people are represented on Wikipedia. So for example, if we are interested in Grace Hopper, a computer scientist, very important computer scientist, we can go to Wikipedia and pull up her page, and then we will see a picture and some text describing her. And we can do the same for Don Knuth, another popular computer scientist, notable computer scientist, that also has a biography on Wikipedia. And on a very simple level, what we set out to ask was, are there any differences between notable men and notable women on Wikipedia? Is there anything that we can measure in the way that men and women are represented on Wikipedia? Is there a bias in terms of including people in Wikipedia? And finally, we are interested in the linguistic aspects of the articles. We want to see whether there are sort of stylistic differences in the way men and women are described on Wikipedia.
My guess is, because I'm in an audience of academics, you don't think about television too much. And that's okay. But I want to convince you that it's a really exciting space to do research. It used to be the case that, people watched shows all at the same time. We couldn't watch things on demand. And you kind of watched them without social media. At least for some of us in the room, we can remember those days. And you came into work the next day or in school, and you kind of sat around the water cooler and talked about what happened the night before. Well, things have changed, right? So viewers now talk about television almost instantaneously when a television show is on. They do so maybe even sometimes before the show is on. What I'm going to tell you today is about how I'm going to use cool data to try to link television viewership to online behaviors. So things like linking it to search, whether people are clicking on ads, and whether people are buying things, okay? And what's special about television, and what's special about the data that we're all generating, is that it's usually time-stamped, so we know exactly when a television show is aired, and it usually has some kind of spatial dimension to it as well. So we know where it was aired. So something as broad as was it aired in the United States, to as general as, was this particular show seen only locally, like local news in Chicago. And so that allows us to do a number of things, a number of creative things, at trying to identify the relationship between something that happens on TV at a particular time and place and behaviors that happen as a result. So generally, we care about who, what, when, where, how, and why as it relates to television using all of these data. So the first project that I'm going to tell you about is linking television viewership to sales. And the motivation behind this is looking at how people spread attention across multiple devices. So can people watch television and buy things? So the next project I'm going to tell you about is one where we looked at television advertising. We have this strategy for creating treatment and control groups for TV advertising. We're able to isolate the impact of TV ads by comparing them. People change their search intent over time as well, and we can track that. So again, this cool data, it's cool not just because, it's social, people are talking about TV, but time-stamped, geo-stamped, and we can ask questions that have been asked for a long time in interesting ways.
There's a bit of a backstory to this piece of research that I want to tell you about. About 2 years ago, in the wake of the Snowden revelations, President Obama asked the National Academy of Sciences to convene a study group of scientists to basically answer the question of whether there were technological alternatives to the bulk collection of metadata and similar data that had been collected by the NSA and other intelligence agencies. Were there technological alternatives that could balance, the counterterrorism efforts of those agencies with some privacy protections for individual citizens? The answer is essentially no. If you want intelligence agencies to work with things like telephone metadata and other social network data in an effective way to counter terrorism, there's sort of no substitute for having that data and to essentially be able to go on fishing expeditions through it, in which from some known targets or suspects, you gradually grow a network of other suspects using that link data, okay? And so the result wasn't that surprising, and I didn't do that much on the study, but it did cause me to go away and think about whether there might be baby steps we could take towards this problem of balancing individual privacy with societal imperatives like counterterrorism. I'm going to use counterterrorism as an example in this talk, but you can also think about the same tension arising, for instance, in the fighting of infectious disease. So this is a talk about privacy, and privacy, as I'm sure everybody in this audience knows, is not only a very polarizing topic, but it's also a very technically confusing topic. I'm going to talk today about a particular mathematical definition of privacy that's been extremely well studied in the decades since it was introduced. It's called differential privacy. The key idea behind differential privacy is this notion that this centralized computation, whatever it's trying to accomplish, should not reveal too much about any particular individual's data. I think maybe the most important thing about this work is not the technical result, but just the showing that there are at least some circumstances in which you can have some sort of sensible balance between, an effective mission and still provide promising individual privacy. More generally, I think that this work is, I think all of the work that's gone on in differential privacy in the last decade is an example of a growing trend, which is essentially endogenization of societal norms into algorithms. You kind of expect that if you have a strong definition of privacy or a strong definition of fairness, and you ask that algorithms meet that definition, there's going to be some degradation of utility of the algorithm. But hopefully the picture will be like it has been for differential privacy so far, which is it really seems that there are appealing compromises between whatever the societal norm is and whatever the goal of the computation is.
And I'm kind of interested in decisions where predictions matter and with enough data. We've sometimes called these prediction policy problems. So let's think about where we might find that. Let me give you a policy problem in the US that may not initially look like prediction, but you'll see immediately that it is. So every year the police make about 12 million arrests in the United States. And when you're arrested because of habeas corpus, you go before a judge. This judge has a very specific, in that 24-hour window, has a very specific mandate. That judge is not trying to figure out, are you guilty, are you innocent? That judge is simply trying to figure out, where will you wait for trial? In other words, we're going to have a trial about this. Are you going to spend that time between now and trial at home? Or are you going to spend it in our comfortable jail cell? So what's a judge doing? You notice what's happening now. The judge, actually by law, if you go and look up what the law says, is actually, in deciding whether to release or not, is asked to make a prediction. Could machine predictions help the judge here? Help how? I guess what I want to think about as a thought experiment is a decision aid. The decision aid I want to think about is a box that sits next to the judge and somehow informs the judge. Okay? And we'll think about how it's going to inform the judge. The box is going to look at the X's of that defendant that it can see and is going to attempt to suggest a modification of the decision. And the question I have is, can this little box plausibly make society better off? Machine learning can be useful in it. Machine learning can be learned from it. But I also think it's important that there are many important policy and conceptual problems where machine learning can be the central driver.